Hello everyone, I'm Waz, and in this video I'll be basically demonstrating the assessment problem 1.1 from the book called Electric Circuits 9th edition, written by James W. Wilson and Susan A. Riedel, published by the Pearson Education. So this problem is basically designed to help us in dealing with unit conversion of, let's say, SI units. Um, so without a further ado, let's start solving this question. So let's read the question firstly. Assume a telephone signal travels through a cable at two-thirds the speed of light. How long does it take the signal to get from New York to Miami if the distance is approximately 1100 miles? So this is a basic simple um, speed is equal to distance by time question, but the tricky part is the unit conversion. But if we can convert the units properly, we can easily get through this question. So firstly, the let's write down the speed. So they have mentioned that this the speed is basically the two-third the speed of light. So speed of light is 3 into 10 raised to 8 meter per second, right? Which is generally represented by the letter C. So that's the speed of the signal, and the distance between the states is 1100 miles. So we are given speed and distance using the distance speed formula. Time is basically distance by speed. So our distance is 1100 miles, and our speed is the denominator, which is 2 by 3, two-third of the speed of light. So two-third of 3 into 10 raised to 8 meter per second. So they want the answer in meter seconds, right? Sorry, milliseconds. So we need to convert the seconds to milliseconds, and we need to get rid of this meters and miles by converting them individually. So let's start our conversion. So let's write 3 and the seconds in the numerator by basic algebra, fractional algebra. So 1100 miles, and we're going to write 3 and seconds in the top, and then we have denominator, which is 2 into 3 into 10 raised to 8 meters. So okay, let's first start by converting the meters. No, first let's get rid of these miles and meters. So in order to get rid of miles and meters, we need the meters at the top and the miles at the bottom. So we need to check one mile is how many meters. So 1 mile is basically 1609 meters. So if we write in terms that miles in terms of meter, we have to write it 1609 meters, which is equal to 1 miles. So we are basically converting this so into meters. So this is basically, if you look at this part, it's basically miles by miles, which is equal to 1, but we are writing in terms of meters. Okay, let's now convert the seconds to microseconds, sorry, milliseconds. So for that, so we know 1 second is 10 raised to 3 milliseconds. So over here we have one, so we'll write milliseconds at the top and seconds at the bottom, and we know 1 second is basically 10 raised to 3 milliseconds. Okay, so let's cancel out a few of the factors. So we have meters, and we can cancel out the miles, we can cancel out the seconds. So now we get our whole answer in milliseconds, right? uh, so if now let's write it neatly. So we have 1100 into 3 into 1609, this thing, into 10 raised to 3, and then we are left with milliseconds, divided by denominator includes 2 into 3 into 10 raised to 8. So if we plug this value in our calculator, we'll be basically getting our answer in milliseconds. So let's start doing that. Let's make further simplification. So we have 3, we can cancel out 3, then we can multiply 2 into 550, and we can make it. So if we perform the calculation for 10 raised to 3 divided by 10 raised to 8, it will be basically 10 raised to minus 5. Now we can plug these values in our calculator. So we have 550 into 1609 into 10 raised to minus 5 milliseconds. This is basically, let me show you in my calculator. So we have 550, sorry, 550 into 1609 multiplied by 10 raised to minus 5. This is 8.8495, which is approximately 8.85. So let's write the answer down. 8.85 milliseconds, and this is the answer in the textbook as well. So we successfully did this assessment problem. Thanks for listening, and see you in the next video.